వాయిస్ ఇప్పుడు అన్మ్యూట్ లోనే ఉంది అది. సో వీడియో ఆన్ చేయి. ఒక్క పాజ్ చేయండి. సార్ ఫస్ట్ డాక్టర్ నీరజ్ V8. మార్క్ ఇప్పిర్తాం. ఆన్ చేస్తాం. స్లైడ్ మార్క్.
Good afternoon, everyone. Welcome you back to the afternoon session of the day 1 FDP. The afternoon session is going to start now by Dr. Kumar Misra, sir, who is the Associate Professor of Vellore Institute of Technology, Andhra Pradesh. To introduce sir, I now request Dr. U. Spandana, Madam, Professor and Dean of Academics, Nirmala College of Pharmacy, onto the stage. Please come.
Dr. Anucps, Science and Associate Professor at the Vellore Institute of Technology in India. Sir has more than 10 years of experience in teaching and research and a senior member of IDB. Sir completed his full-time internship and the technical institute quality improvement program, Government of India. And sir received gold medal scholarship from Dr. A.C. Abdul Kalam Technical University in 2019. Sir completed his BTech and MTech in first class and his PhD. And sir completed postgraduate diploma in mechanics, machine learning and artificial intelligence from NIT. Sir awarded a faculty development program from AICTE and ISTE under the Induction Preparation Program titled Pedagogy Innovative Methods of Teaching and Learning as the store coordinator. It's really great. And sir received the Anucps grant from the Ward from AICTE. Sir is the inventor and coordinator of seven Indian patents. Those are complex. And sir received the grant, one Indian patent grant, and sir received the three grants from the international patent for the international patent domain of quantum computing. Sir authorized and authorized more than 50 research publications from the Scopus and created international journals and conference proceedings. As well as third published 15 book chapters with spread. Sir author and founder of three international books. Sir was published in various high impact factor papers that are quantum computing, reversible computing, QCA, and dynamic process aspect. The third is 45 students are completed and the third is 5 PhD scholars currently pursuing their PhD, and one PhD scholar has successfully completed and award quantum strength from IBM Global Summer School 2025. Sir received two best paper awards from Anucps University Noida, and second one sir from the NIT section Assam, India in 2022. And sir is a professional conductor including ISTD, SEM, IDE, all research council. Sir research interests include quantum computing, reversible computing, fault tolerance, circuit architectures, QCA technology, nanomagnetic logic, design for test computing, and low power and reliability awareness. This is the sir edition. Our event, here we are to learn your presentation. Thank you. Thank you.
Good afternoon to all the faculty members and all the participants. I am Dr. Neeraj Kumar Misra. I am the Associate Professor from VITM University. And today I am going to discuss about a very interesting topic like quantum algorithms and AI techniques and the biomedical image processing using a software like IBM QCA. Okay, so first, okay, so in my hands-on session, I will discuss how the biomedical image processed by quantum circuits and how to enhance the image. So this is a very important scenario here. I will do this practical session after in my last half an hour. Okay, so why this quantum education initiative is taken by the AICTE? Okay, so quantum education, quantum minor courses, which is already launched in many engineering college, AICT affiliated college, and this proposal is taken by AICT, DST, and NQM. So, what are the major themes they have focused in this minor degree course? There are four major courses are there. One is quantum computing and simulation. And second one is quantum communication and cryptography, quantum sensing, quantum material and device. Okay, so for the minor degree course, there are minimum 18 credits required for minor degree course, and each course is three credits. Okay, so this is already launched by the AICT, and many of the affiliated AICT affiliated colleges all started this course. Okay, so these are there. These are the 12 courses.
Slide or this. Zoom log. Basic slide, sorry. The black ones. Yes, yes. Schema. Wait one. Yes, yes, yes. Enter screen log. Slide by slide. Look, go to slide. Yes. Enter on screen. Front of the screen. Share.
by 30.
Video is sir, video.
ట్రిపుల్ ఎంఎస్సి అంట
Okay, sir. Slides చేయండి.
So, this minor degree courses is launched by the AICT in all the AICT affiliated college. So, you have to some aware about this quantum technology, what is that development or what is the recent things are going on in this quantum technology. So, minor degree course is already launched by the AICT, and what are the courses are there? 11 courses are there, and each course is 3 credit. Okay, why this course, quantum computing course is important for undergraduate students? Because in the global market, there is a more demand of the skills people who know the quantum technology, because the more development is actually going on the quantum technology. So that's why if the UG students are properly trained in this technology, then we can fulfill the market requirement. Okay, so national and global opportunities are more, and this is an interdisciplinary branch. So that means all the branch student, maybe physics, mathematical, or chemicals, or biomedical, or electronics, or computer science, any branch student to be come forward here in this technology. So that means if the skills people are more, that means the employability increase. Okay, so that means India will also come to the global leadership, because nowadays many of the country is making a superpower in the quantum technology. But our country is not in this top 6 country. So that's why the AICT have AICT DST or NQM National Quantum Mission has taken the initiatives, and they launched this course to fulfill the market requirements. Okay. This is my book actually on the quantum technology. If you're more interested on the fundamentals about the quantum technology or do some projects or research, you can go in this book, and it is also available on Amazon. Okay, so first thing I need to discuss what are the central government have taken the initiatives to develop this technology. So in 2018, the government has launched this scheme, Quantum Enabled Science and Technology. And after that, in 2020, the government has launched another scheme like National Mission on Quantum Technology and Applications. And 2021, the Quantum Key Distribution. This proposal have launched by the central government. So at that time, there is no more awareness about that technology to all the academics or industry. But now the government has launched one more scheme that is very much more popular, that is National Quantum Mission. And that is launched in 2023, and in 2031, the project will be complete. So in this scenario, they are around allotted more than 800 crore budget for this development of quantum technology. And most of the government organization is actually coming forward to launch this project successfully, like DST, DRDO, and so. And so they have made some T-hub to launch this project efficiently. There are 4 T-hubs in our nation. One is IST Bangalore. So this institute is looking at quantum computing work. IT Madras and C-Dot is looking on the quantum communications. IT Bombay is looking at sensor and metallurgy area, and IT
Is it
Delhi
okay? No
material
problem.
and
No.
devices. Okay, so if you see the National Quantum Mission is not for a single state. It is they given the fund to whole India. Means all the states are covered here. You can see all the state have the government has given a huge fund to develop this technology. So that means we are the responsible person. First, the faculty and also the academics or industry person. They have to do some startup or some patent filing or some projects. Then the technology will be go or may come to the mature level in our country. Okay. So if you see the whole worldwide, other countries actually allotting a more fund for this quantum technology. But now without quantum technology, we cannot make our products to be more efficient. The product may be like medicines or maybe communications devices which are used by ISRO or DRDO, everything. So that means other countries allotting a huge fund for this quantum technology. That's why all 6 countries leading in the whole world. I will tell you what are the countries are leading in this quantum technology. Okay, so now the quantum is not a new thing. It is already the quantum day on every 14th April. So this day is very remember you have to remember every day we are every year we are celebrating a quantum day. Okay, now what are the initiatives taken by the state government? Like you see, the Bangalore state minister have launched a Q City, which is working on many domains like R&D clusters, make a new materials on new quantum made by India computers, quantum computers, and there are huge data centers which is based on the quantum and incubation centers and the processor and the components. So this initiative is taken by the Bangalore state minister. Not this one. In our state is also government has launched this project that is Quantum Valley, and you know this project is a very huge level. Okay, around 100 acres they allot space, and most of the big company will come here, and these all companies working on a different area actually. Like pharma industry, they call actually many pharma industry also come here, and many of the industry setup will here. That means there is a huge demand in the market for the job point of view. But whatever we are facing a problem, the skills people are not in our country. That's why we have our AICT has launched this scheme or minor courses started in all the AICT affiliated college, and many of the online courses or MDP program is also going on to satisfy the customer requirement. So there are 4 companies in Quantum Valley. There are 4 big companies actually. The tie-up is there. So very soon the project will be start, and if the project start, there is a huge good products come in the market. Not in one sector, it come in all the sectors like medicines or new materials. Okay, and made by India quantum computers. And during this national quantum mission, which is complete on 2031, our country will also come in the superpower. That is the main aim of the central government scheme. Okay, so first, what is quantum computer? Why we go to quantum computer? What is the emergency of quantum computer? Why we are not using normal computers which have high processor speed capability? Because this thing is not solved, because the conventional computers what we are using in our home, that will not solve bulk data. If you have a bulk data or huge data, then it is not solved the problem by the conventional computers. So you see the previously we are using a vacuum tube that is very bulky, very high cost. So at that time, mostly the scientists or the industry people are using computers. But after that, the scenario change. The silicon-based materials are there. That's why the computing or device reduce. mass reduce, and that's why every people are using computers in our home. And after that, there is a huge scenario change. The new computing device come in the market, that is quantum technology. So in the future, this technology will survive to satisfy the customer requirements. Okay, so what is quantum computer? Quantum computer is use quantum mechanical phenomena to solve any complex problem with a fraction of time. So what are the properties is there in the quantum computers like entanglement, superposition, and tunneling? So these are the specific features are in the quantum computing computers. That's why the computing power increase. Okay. Okay, so the quantum supremacy. So the quantum supremacy is already reached by the US and China. These are the two companies leading in this technology. So if you see the Google is a US company, US search engine company, which is already developed the quantum computer, which is 49 qubits device. And the China also reached to the quantum supremacy. Okay, and Google is also make a 72 qubit processor, which is more, which can solve a complex problem, more complex problem like weather forecasting. Okay, and the new medicines development. That's why this computing is useful for all the scenario. And in the morning time, I told you the COVID vaccine is developed by quantum computer. That is correct. Because you know the COVID molecule is very, very complex. If you see the structure, if you put this structure on your conventional computers, conventional computer will not solve this problem. It takes around 10 years to understand this COVID molecule, COVID virus. But the quantum computer immediately understands this COVID virus, and then the scientist people identify the correct medicine. That's why it's more demand. The quantum computer is more demand. Not in the medicines, it is also applicable for banking sector also. Because in other countries, if you see, the security system is very high. So it is not possible to anyone hack the system. But our country is not using this all computing devices. So that means we are in critical stage. That's why the central government is looking this technology very seriously, and they have uh, given the fund also around 800 crore fund for national quantum mission. Now you see what are the principles we are using in quantum computer. One is superposition, entanglement, and interference. So in superposition, there are multiple states. All states are superimposed. Then we can measure any information in time. But in the conventional computers, there are only 2 bits, 0 and 1, and we do not know other state. So that if we throw a coin on the air, the coin is rotating on the air, and we do not know what is the head or tail. If the coin is stopped on the earth, then we can measure the information. But quantum computer give you all the informations in any state of time. So entanglement is the property to stabilize the correlation between two particles, and these two particles is very far distance. So if you measure a one particle information, other particle information, we can identify because the spins are opposite spins are there. So if one particle is spin up, the other particle is spin down. Okay, by the entanglement, we can observe the particle behavior, and that is not possible by the conventional computers. And it is very helpful for communication purpose like cryptography applications. This entanglement property is very useful. Okay, and the last one is interference. Interference is the property if you measure information, then we can observe a correct information. Because in the previous state, all the states are superposition state. All states are combined. Then we cannot identify the correct information. So during the interference, we can observe a correct information. Now, the quantum computing is applicable for many areas. One is artificial intelligence and machine learning. Because nowadays the data set is very huge, and if you apply any machine learning models, okay, like if you train your machine, it takes huge time for the training and of course the testing also. People most of the time they allot the data set 70% data set for the training and the remaining 30% data set to the testing. But in the training phase, the processing time is very high. That's why the convolutional computer is struggle a problem to training or during the training a machine. But the quantum computer can do this problem very quickly. But they have a superposition property or entanglement property. That means the quantum computer accelerate the AI and ML applications. So if you integrate quantum computer with AI, then it will be more accelerated. And the accuracy point of view is also very good. Your machine will be trained very quickly, and the predictions of machine prediction is very easily. And the quantum computer is used for chemistry also, and also the drug design and developments, because the computation power is high in the quantum computers. It is used for cyber security also, and finance modeling, and logistic optimization, and weather forecasting. So these are the actually major application of quantum computers. Okay. Now, actually, when people are thinking, what is a real device? This is only the virtual things. No, this is not a virtual things. Existing the quantum devices are also there in the market, and most of the industry are using quantum devices for any computation, for any complex task. And tools are also there. In academic sites, you can use tools also, which is freely available and which is based on the Python. You cannot learn any new language like Java or PHP. It is not required. You just, if you are aware about the Python or C++, you can easily write a code using Python, and you can use a quantum device. Okay, so the quantum device is work at a cryogenic temperature. Means the quantum hardware only work on this 0 Kelvin or minus 273 degrees centigrade temperature. Because here the superconductive qubits hold the quantum property. If the temperature is not maintained in the quantum device, then the superposition property will be lost. And the computing is like classical computing, is not a quantum computing. So that's why the quantum device must be work on the cryogenic temperature. That means more cooling processes are required. That's why many tubes are there. In the tube, we are passing gases to cool a processor. So recently, IBM has launched this quantum hardware that is 65 qubits, and you can see the Eagle processor, which is developed by IBM, which is 127 qubits, which is more higher capability. Okay. And also you can see the IBM is also developed this 43 qubits processor. So this is a real scenario. That means the development is going on very fast. Okay. Now you see this is a view of quantum computers. And if you are interested to how this computer will work, you can just click on the YouTube. You just see the total view of quantum computer, what are the look of quantum computers. Okay, so now if you are working on your some projects or some funding projects, then there are many tools are there, which is open access. You can use any time in your place. Like IBM has developed a tool, it is Qiskit tool, and it is free. And the Microsoft Quantum Development Kit, Rigetti tool is Forest. Okay, and the Google has also made this tool. You can also use freely. So there is a huge possibility actually for your doing research, maybe your drug discovery, okay, or new medicine discovery. Everything is possible in using this tool. And of course, these all tools are using a Python-based library files and the Python coding. And Python have a huge demand because it is a very simple language as compared to other language. And there is a huge community of Python. If you have any bug in your projects, you can ask your doubt to your community, Python community. They will respond to you. That's why this language is more popular, and that is a world first popular language. It is a very popular language. So that Python is the top level language. Most of the industry people are also using this Python language. Okay, and these are based on the Python. Okay, so many of the company is coming forward. They are making a tool, and of course, present time it is free, but after some time it will be licensed tool. Because industry needs revenue also. Okay, so it is not possible for a long time free or open access. Now, days before 4 months, this IBM has making some restriction on Qiskit tool. You cannot run your job on a real quantum computer. You can run one job for 1 day. So that is a restriction. If you want more simulation or more time, you have to give the credit card information. They will give you the time-wise charges also. Okay, because this technology is growing very fast, and this IBM has released the data set also. Most of the user from India. The Qiskit tool is used by most of the people are using from India. That means most of the people are interested to learn this technology. Okay, and because if you access the computer, they can identify your IP address. Through the IP address, they will identify your all information, which state you belong, everything they will trace, and they release the data set. Most of the user from India. Okay. So if you write some code or some projects, and if you want real-time simulations, so you have to create your login, and from the login you have to identify your IP API token, and this API token you can access any computer for some time. Okay. Because this all simulations are real time. It is not a virtual. It is all simulations on real time. That means you are going to access an IBM computer to run your job. Okay. And what are the benchmark tools, parameters you have to focus for your projects or your medicine developments or drug discovery? What is gate fidelity? So gate fidelity means what is the quantum gates you are using that is accurate or not. Okay, because sometimes if you are simulating your job, it have more faults, more defects. That means the quantum gates are not perfectly matched to your circuit. Okay, another is quantum volume. Quantum volume shows your performance of a circuit. Okay, and whatever the resource you are using, that resource must be less to show that your project cost less. Okay, do not utilize more resource or more quantum gates that increase your cost. Error rate must be low, and T1, T2 times must be low, and the execution time must be fast. So after running your job, you have to check all these parameters, and then you show that the project is more efficient or more perfect. So I am going to discuss this tool, Qiskit tool, which is now open access. You can use this tool in your computers by using any Jupyter platform or PyCharm or Google Colab. But you have to install library files. You just create the environment of a Qiskit. Then you can access any quantum computers, and then you can start your projects in your place or in your computer. Okay, so these are the some types of code is there in the what is Qiskit tool. So first line we are importing a library files. Okay, if you are using a first time, then it will be installed online. Okay, if it is installed full time, next time you cannot, your job will be directly run. And we have used some backend library files for the practical simulations or measurement that performance of a device. Okay, so you can see here we are using a backend aer.get. These are all the backend library files. But this pink color, what I showed to you, this is your job. Okay, this is your hardware design. Okay, so this hardware is capable to do some image analysis or some AI applications or for training purpose or new medicines discovery, because this is your job. Okay, this is your coding part. Okay, and the upper two line and the last four line is used for the only simulations. Okay. Now the IBM Qiskit tool have a because this is total hardware. It's not a software. It is both hardware and software. So that means you are writing some Python code, and this code go to the real quantum hardware. That means we are using some layers on cloud. Okay, what are the layers on the cloud? One is Terra, Qiskit Terra, and the second one is Aqua, and third one is Ignis, and the last one is AR. Okay, so these are the layers we are using quantum computers. That means with the help of these layers, your job will be go to the real quantum computers. And the real quantum computer will give you the simulation results. Okay, so I'm going to discuss all these layers, not more depth, but just give the some practical idea how you can start your project work or your patents or your research paper. Okay, so the Terra is the layer to helpful to code dump into the hardware, because this is the interconnection layer. The code dump to the hardware, because of course you are accessing quantum blocks in the real hardware. So the Terra layer is responsible for the accessing the hardware with the help of code. What you write a code, Python code, you can access a real hardware. Okay, I just show you in this slide. You know, we are surviving in Earth. So in Earth, we need some base where we are stand, and we need air, and we need fire also to make foods or many things, and the water to survive our life. Similarly, the Qiskit tool is also like that. The Earth is like a Terra. Okay, and the air is like a AR, and the fire is like a Ignis, and the water is like a Aqua. Okay, so you can link this module with the practical life, how you survive on your Earth. So what is a Terra? Terra is the actual hardware, actual components. What are the quantum components are there? It is like Earth. And the AR is like air. Because without air, we cannot survive in our Earth. That means if you are designing some kind of hardware or some kind of circuits, you have to simulate your job on real hardware. So simulation means it is like air. You just check, you can check your code will survive or not. Okay, and Ignis is used for the noise. Okay, noise means many faults are there in your jobs. Some output is not as per your expectations. So you have to use Ignis layer. Ignis is the layer which is helpful for noise. So of course it must be less, then you can say my jobs are more accurate, more perfect. And the equal layer is used for the algorithm development. Because nowadays the quantum algorithms are very less, and if you are good in the algorithm writing or make a blueprint of your design, you can you can contact to the startup company. They will hire you, or they want to purchase your products. Okay, or you can file a patent also. So for the new algorithm developments, the aqua layer is helpful for to develop a new algorithms. Okay.
Okay, now this is already covered. So if you design some kind of circuits, so you need to optimize. Otherwise, the hardware cost is more. Okay, because if you use a more resource, that means the cost increase. That means it is very difficult to manufacture any hardware. So the RC viewer is a tool to optimize your job. And if the job is optimized, you can use the Qiskit tool. Qiskit tool will be helpful to run your job on quantum hardware. Okay, so many of the researchers who is working on the optimizations, okay, you have to link these two tools. One is RC viewer, another is Qiskit. Okay, this is a very research-oriented slide. Those who are very much interested for the optimizations, you have to interconnect these two tools, okay, RC viewer and Qiskit. Then you can optimize your job in terms of less resource and higher performance. Okay, so I already told you in the what are the layers are there, how you can manage all these layers. So ERA is used for noise modeling. Ignis is for error or mitigations. Terra is used for circuit creation or optimizations. Okay. So quantum hardware is a high-level architecture of Qiskit. Okay, because the Qiskit is the hardware. It is not a tool. It is a tool, but it is linked to the hardware. Okay, it is a complete package. We can say it is a complete package. If you are using a IBM Qiskit, it is a complete package. So now in the we go to more practical. Suppose that if you are more interested to do some practical work. So if you want to make your circuit or if you want to make your hardware, so you have to import some library files. Okay, the first slide is showing the importing of library files. Okay, if you import the library files, then you can call any hardware or any blocks for your hardware design. Okay, code I just written here. And for simulation purpose, simulation is the verification of your hardware. It is working properly or not. So this is the library files. You have to use these all library files for the backend process. Like I written from Qiskit ER simulator. Okay, so these 4 lines, what I'm showing to you, it is a standard library files. You cannot change. You use this line in your job for checking the simulation or doing the simulations. Okay, and in the noise characterizations, okay, so you have to use this library file. It's a one line only. Okay, you have to use this library file and run your job. So after that, you will get your noise parameters. How much noise in your circuit? Okay, then you can see my hardware is more good performance because noises are less. Okay, what are the noise? Bit flip noise, depolarized noise, okay, and coherence noise, that must be less. Okay, and the aqua is for the algorithm developments. Okay, these are the 2 lines for the algorithm developments. Okay, so this is a complete summary. What are the 4 layers in the IBM Qiskit? So if you know this all functionality of the layers, then you can use the Qiskit tool for your job. Okay, later I will tell you how you can create your jobs and how to simulate a job and how this job go to the real quantum computers. Okay, so qubits and quantum gates. So what is qubits? Qubit is the information of quantum computers. Because most of the digital circuits you are using in your mobile or laptop, all are digital circuits. Means we are computing only 0 and 1, binary 0 and 1. Okay, but the quantum computer is used as qubits, not bit. Okay, so we can say that the conventional computers or all the computing device we are using it based on the logical gates, which is using a bits. But quantum computer use a qubits. Okay, so one thing I need to clarify Can quantum computer replace the conventional computer? No. Yes, because in the normal computers, we are accessing browsing or word processing documents. Okay, that is a normal computer. But quantum computer is only used for high-end applications like weather forecasting or drug discovery or new material discovery or cryptography applications, finance sector. So in that area, quantum computer is very helpful. Conventional computer we can survive. It can quantum computer will not replace your computer. Okay, but for higher end applications, quantum computer is required, which is not possible by the conventional computers. Okay, so what is the qubits? Qubits is kit 0 and kit 1. It is written here, kit 0. This is a matrix part. All the computations, all the processing is based on the matrix computations. That's why the computing power is fast. And that equation, what I kit 0 plus beta kit 1, it is denotes the superposition equations. So you can see both states are combined, 0 and both states are combined. But in the conventional computer, we are using only one information at a particular time, maybe 0 or 1. The other state we cannot access. But in the quantum computer, we can measure all the informations at any time. Okay, so actually all the states are superimposed because here 0 plus 1 is combined here and both are have 50% probability of qubits. Okay, and you can see the circle. This circle denotes the loss sphere. It gives the quantum information. But in classical computing, like your mobile or your laptop, it is using a bit 0 and bit 1, no other state. But in the quantum computer is a sphere. That means this line state vector is rotating in the on the sphere. So we can measure all information at any time. Okay, so these are the measurement or wave function measurement. Of course, we do the measurement, we only see the classical information. The quantum information is both equal probability, 50% probability of 0, 50% probability of 1. So that we cannot say that it is a correct information. During the measurement, you have to use only the classical information. Now you can see there is some kinds of gate, like 2 qubits gate, which can perform all the operations on the real quantum hardware. So this is some kind of 2 qubit gates. Q0 and Q1 is the qubits. Okay, and this is the dot represent a control point, and this plus sign denotes a target qubit. Okay, this is some kind of functionality table of quantum gates. And this is some kinds of rotation on the loss sphere. Okay, so just now I say you one statement. There are very less number of algorithms are there in the quantum area. So industry need a person or researcher who want to develop a quantum algorithm. So there is a huge demand now in the market for good algorithm developments. Because some person has used the algorithm, you can see all the qubits have equal probability, like 13%, again 13.75, 0.7, 20, 12.8. It is almost equal. That means it is a worst algorithm. This algorithm is not good. How we can measure correct information? But some person or some industry are very good in that or mature state, like IBM and Google. So they make algorithm, and this algorithm you can see this one information has 74% probability. The algorithm which is developed by the engineers, that is more knowledgeable person. They have used this algorithm for simulating our jobs perfectly. Okay, so in quantum gates, why quantum gates require? Quantum gate is processing your information in the real hardware. So there are many gates are there, poly X, poly Y, poly Z, or this Hadamard gate. Every gate have a matrix. So these are the matrix we have shown here. Okay, because this is a mathematical side. Or if you want to learn any hardware, you have to understand the matrix of gates. Then you can observe quantum gates behavior. Okay. So this slides is only just use the information about the matrix. What are the matrix are available in the for quantum gates. So how you can enable your device on your simulator. Like if you are using a Qiskit tool, so I am writing this code. This code is quantum circuit 1, 1. 1, 1 is denotes the qubits. So one information is that one output information. And H0 means it is a Hartmann gate. Okay, and dot measure. Dot measure means measuring the information. Okay, what is the output information? And draw. Draw means this is the visualization of a circuit. Okay, so you can do this code, you can run this code and the circuit will be enabled in your simulator. And then you call this block to your in your job for new material discovery or new medicine discovery. Okay, because this circuit is helpful for your job to be run on this device. So you can see this Hartmann game have equal probability of 0 and 1. Okay, 0 around 507 count and 1 is around 493 count. Both are equal probability. Okay, so if you see the real hardware, what is used on the real quantum computer, that is default T gate. Okay, so you just double click on this circuit, quantum circuit, then the internal blocks will be enabled. What are the internal blocks? How many T gates? How many T plus gates? Well, all these are quantum gates. So if you are using optimizations, so you have to use less number of gates in the internal blocks. That is again optimization. But if you optimize, then you can say my hardware cost is less and it is cost effective. It is useful for the manufacturing. Okay. Now, Python. Everyone know Python. Okay. So in this slide, I'm going to discuss how you visualize your graphical diagram with your simulator. Okay. So what I'm doing, this is the node. It connected to node B. That means there is a interconnection between node A and B. So I am using this code. Okay. It is very much useful like a data structure. If you are more interested for the data structure, how the node is connected to the child node, what is the connectivity, what is the behavior. So similar things we can use in the quantum world. Okay, because these things is used in the data structure or in the computer science branch. But we need to install this separate library files for a quantum computer, like pip install graph py. So this installation is helpful for your quantum circuits graphical design. Okay, graphical design. Okay, so you can run this code in your Jupyter or your PyCharm or Google Colab. Okay, or Python, any compiler. Okay, after that, so you can see here I written some code. This is some kind of Python code. And you see in the right side, this is a graphical diagram. So this graphical diagram is showing your connectivity. How the input is go to gate, what are the gates is connected. And after this gate, what is the output? Because everything is come in the graphical design. Because this Q0 is connected to CX, CX is the gate, control not gate. And after that barrier, again measurement, and measurement, there is a Q0 measurement, Q1 measurement. Okay, so you can visualize your graphical design, okay, by whatever your quantum is. Okay, so nowadays the machine learning is more popular, and what are the algorithms are there? One is algorithm is state vector machine, SVM. SVM is a technique to train a machine properly. Okay, so I am going to discuss the SVM technique in the machine learning. Okay, you can use this SVM technique to your job. Okay, and you fit the data. If the data is properly fit, then your overfitting or underfitting problem will be resolved. Okay, then you can say the machine training is very perfect and the production is very good. Because nowadays the machine learning engineer facing a problem of overfitting and underfitting. The problem is bias and variance not set properly. If this two parameter is not set properly, the prediction is wrong. Okay, so SVM technique is used to fit the data properly. Okay, so here we are using a boundary. Okay, suppose that you have two data set which are segregated on a cloud. So you have to take one line, a boundary. So this boundary separate the two data set, because some data set you taken like cat and dog. Okay, both to be separate. Then the machine will understand this picture, 100 picture is for cat or 20 picture is for dog. So that segregation is important. So that is possible by the SVM. Okay. So more than two class, if you have more than two class like cat and dog, I taken two examples, then you can apply SVM technique, okay, to separate the data set or separate, because if more classes are there, you have to give their training information to your machine properly. Okay, so what is hyperplane? Hyperplane is a boundary to separate the different class. Okay, I'll just go to the terminology what we are using in SVM, which is used for machine learning. Okay, then we understand the practical scenario also, how it is possible. So if you separate the two data set, what is the margin? Margin must be high. Otherwise, if the data set are very close, then the problem is overfitting and underfitting. Okay, so the margin must be high. Okay, whatever your support vector, that margin must be very, very high. Okay, so the support vector which is located on your data set, okay, which is used to separate the data set. Okay. What is a clear picture SVM algorithm? Suppose that I use some blue color, some star. That is some kind of data set like cat images. And I use some green color dot. That data set is for dog, different types of dog. Okay. So these two data set is separated by this line. That is hyperplane line. So using this hyperplane, we can see that the two data set are separated out. That's why the machine learning engineer are making a hyperplane to separate the data set. Because if your more classes are there, then the problem is the merge data set is merged, and then you cannot give training to machine properly. If the training is not good, the testing is also fail. Okay, so that's why we are using a hyperplane, and this SVM technique is very helpful for more than two class. Okay, so you can apply this SVM technique to identify the person is using a mask or without mask. You can identify the cat or dog, or you can identify the this company product go to up or down after this year or present indications are there. Okay, suppose that some director is launching a movie. So based on the previous data set, we can predict this director movie may be hit or flop. So all the engineers are working on are using this SVM technique to predict the output in the next stage or in the next year. What is the product? It will survive in the market. The customer will buy this product or not. Because here the SVM technique is segregating the data very perfectly by using a hyperplane or using a great margin of separation with the data set. And then training is very perfect. There is no problem, low bias and high variance. Then the data set will be trained properly, and the ROC curve, like reason of coverage, is go to linear, very linear. That's why the people saying that this model is perfectly predicting the output. because they know the separation, how to separate the class with SVM. Okay, because all things are mathematical. If you use this SVM, that means you have to identify the line equation with the help of slope and intercept. Okay, because your data set is in the CSV format or Excel format. So that data set go to the segregation or in the two-dimensional space. Okay. Okay, so now how this quantum computer is helpful for SVM. Okay, this is machine learning algorithms. If we are using a normal computers, there is no, because every time we are tuning activation factor or the weight of a like your data set. If the weight is not good or activation factor is not good, there is a more problem in the tuning. Tuning means your data set is not good trained. There is many problem. But the quantum computer is have a backtracking method. So using the tracking method, you can easily identify this data set is not trained properly if the prediction is wrong. But that is not possible in the classical computer. That's why all the industry is moving to apply the what is machine learning algorithms to quantum computers. Because quantum computer is going give the training very fast, and if the training is very fast or very accurate, the prediction will be very perfect. Okay, so that's why this research is going on, and of course this AI ML is going very means the development is going on very fast. So in that way, the quantum computer will be helpful to give the machines prediction very accurate. Okay. Now the quantum advantage using machine learning. So in healthcare or drug discovery is very helpful. Of course, it is very helpful because in the healthcare, whatever you take in a biomedical image, I'm going to discuss some project work also. If you are using a biomedical image, that means the image is in the pixel form. You have to identify the pixels and make a matrix and apply this matrix to your hardware. But the hardware is not perfect. The conventional hardware is not perfect to recognize your pixels in a less time. That's why the simulation go to 24 hours or 2 days to simulations or maybe 1 week simulations. That is a problem in the conventional system. That's why the drug discovery or the pharma industry is also moving to the quantum computers. Because they are facing a problem in the computation time or latency will be very high.
How much salary and working?
So in the finance sector, the optimization, market predictions, the share market price, what is the future price. So that will be predicted very fast by the quantum computers. Okay, like in finance sector is very good, and healthcare or drug discovery, the quantum computer will be very helpful. And in the quantum valley projects, the government is launching a project very soon, like pharma industry, by the quantum computers. They have already released the circular also. Because after that they go for the new manufacturing developments. But the first thing is the
Correct.
drug discovery, which is
ఇది ప్రింట్ కావాలి.
okay. So how we start some programming part? Because now this FDP program is not like a theoretical. We have to do some practical study, which will be useful for your research or some projects. Okay. So I'm going to discuss the programming in IBM Qiskit. IBM Qiskit is an open access tool you can use in your laptop. So there is a programming part. There is no new language you have to learn. You just only understand the fundamental of Python. And Python language is very much similar to C language. Okay. And it is very simple. So let's move to Python programming using IBM Quantum Lab. So IBM have it's not touch screen. So IBM has given the open access tool. Any person can use this open access tool. That's why most of the researcher or most of the academics or person are using this tool. Okay, IBM quantum computers. So there is a two feature in there is a two tool. One is Composer and is Quantum Lab. So in Composer, there is no need to write the code. There is a library files. You can see these is the library files which have some quantum gates. You can use with job. No need to write any code. Just drag and drop on your workspace. But some people are interested for, some people are expert in the programming or Python programming. So in that case, you use IBM Quantum Lab. This is a Qiskit. You have to write a quantum assembly code. Okay. So you can choose first one platform, which tool you are going to use, maybe Quantum Composer or maybe Quantum Lab. Okay. So Quantum Composer is a GUI based. GUI means graphical user interface. All the graphical gates are there. You can drag and drop. But Quantum Labs, you have to use some codes. Okay. Now, how we start the programming? So many faculty have know how to. They are working on the Jupyter notebook. Okay. So in Jupyter notebook, you can use the IBM Qiskit, but you need to install the library files to create an environment of quantum computers. Okay. Then you can do other tasks like your drug discovery or biomedical image. Everything it is possible, or AI ML applications. So in the practical scenario, you have to install these library files, but is pip install environment kernel. Of course, you have to connect your system to internet. Then it will be slowly installed all the library files. Okay. So another is pip install Qiskit. Okay, pip install Qiskit AER. These are the environment you have to set up. If you are working on first time on quantums, uh, quantum library files in your Jupyter notebook. Okay, after installation, we have some library files, some backend library files. So library files is your verification of your job. Okay, and the backend is your simulation part. Your if you do some simulations, you have to use the backend library files. Okay, so there are 10 library files we are using for standard library files, and total 6 library file is for backend. Okay, so this line you copy in your job because these all things are standard. We cannot change. It is developed by the IBM. Okay, and because these library files is helping to your code dump to the real hardware. Okay, because these all things are practical or real time. It's not a fake simulation. It is a real time simulations. So that's why the backend library file is helpful for the simulations. Okay, so now if you are creating your job, then through the cloud you can dump the code on a real quantum hardware. Of course, it is queue. Means if you run your job, your time, maybe some other jobs is running on quantum computers. The time will be also shown. After 5 minutes, you can dump your code on a real quantum hardware. So because many people are running your job on a real quantum hardware. So you have to wait some time because the time will be also shown. This time is required for queue, and after that your job will be go to real quantum hardware. Okay, so my research work, I need to discuss some research work. Most of people are interested for research, or student also. They want to some projects or some capstone or any projects related to final year. Because I need to show you some research work how it is possible. So I am going to discuss the biomedical image. If you have a medical image from like bone image or head image or heart image. So how the quantum computer will enhance your image? Okay, so that thing I need to discuss. It is helpful for you also. You can start your work on biomedical images. Because nowadays the project must be application oriented. Application means you have to show the application, how this project is helpful to society. Okay. So first we need to learn what is digital image. Digital image is three types. One is binary. The pixel value is in the binary form 0 and 1. Another is gray. Another is color. These are the three images. Color means there are three color RGB, red, green, blue. Okay, this thing you know very well. These are the digital images, three type of digital image. So binary image, you can see the clarity is not good, but the gray image, the clarity is good. And the color image, there are three matrix RGB. That's why it is more colors or blue and you can observe all the colors. So this is some basic introduction about the images. And if you want to see the image matrix, there is some code. You just browse your image on your in your Jupyter notebook. They will give you the matrix. So in the binary image, you can see only 0 and 1 are there. Some pixels are high, some pixels are low, like black and white. Okay. So black means pixel value 1, binary 1, and white means the pixel is 0. And the gray image come to 0 to 225. This is the range. So every pixel value you can identify the matrix. Suppose that if any image is high quality or high definition, the pixel value must be high. For high resolution or high HDMI image, okay, that depends on the pixel value. So in color image, there are three matrix. One is red, green, and blue. Okay, so these matrices will identify the image quality. Okay, and if you merge all these matrix, the matrix size will be more number of rows and more number of columns. Okay, of course it is a big size. Okay, but matrix computation is very easy in any simulations. Like you see the MATLAB tool, which is also based on the matrix simulations. That's why it is very fast. The computing power is fast. And also the quantum computer is also using matrix for computations. Okay. So how this converting classical image to quantum image? Because if you are using a quantum hardware, we have to follow some methods for quantum image representations. Because this is not a conventional computer to process your digital image. This is a quantum computer. So we have to follow these are the representation of an image. So what are the images are there? There are 5 types of representation of quantum image. Of course, you go to mathematical side also. Because every representation, we need some mathematical equations or mathematical modeling. Because those person who developed this algorithm, they have make a mathematical model. Okay. So suppose that one image representation is FRQI, flexible representation of quantum image, and NEQR, NCQI, NCQI, and FRQCI. These are the images in the quantum computers. So why we use quantum computer for biomedical image? Actually, the quantum computer is exponentially fast as compared to classical system. That's why we are using a quantum computer. The pixel computing is very fast. Okay, that's why we are using a quantum computer for biomedical images. So what is the comparison? Because this data I collect from the research paper, every algorithm has some advantage, some disadvantage. 5 minutes. So these are the advantage and disadvantage of all these methods. So I just told you in all the algorithms there is a mathematical equations for the representation of pixel value. Okay, you can see the mathematical expression of images, how to represent a pixel for any image. Okay, so for biomedical image or biomedical equipments is using a BCD format display. Suppose that if you have data which is more than 9, decimal value is more than 9, That means the correction is required in the medical equipments. Okay, so here if you have two sample data, means this is a heartbeat. You have measured the heartbeat, one point patient database is 78, another is 84. So if you add 8 plus 4, that is greater than 9. That means we have to use the correct, we have to correct this information. We have to use below 9, then the display will be correct. So all the biomedical equipments is using the overflow detection. Overflow detection. Okay. Because we need to display a correct information on the display device. So there is some kind of quantum gate, quantum circuits, which is used to identify the overflow. Okay, if the information is overflow, then the display is wrong. But there is an inbuilt feature in the biomedical. Automatically, the correction will be in the device. That means some kinds of electronic circuits are there in the biomedical device. So suppose that I collect this all information, A naught, B naught, it is a binary information, this go to overflow detection circuit, and overflow bit, if you see all are 0, there is no correction, the display will be proper. But if the overflow bit is high, that means there is a correction in the biomedical image. Okay, so that means if it is 1, there is a correction. Okay, so this is the algorithm. I just show you if the bit value is greater than 9, then it is a correction. If the below 9, there is no correction. So what is the image enhancement? Which we are using, we have to use the NumPy. NumPy is the library file to convert all these image into gray style. And then we have to use enhancement operation to identify the pixel value which is greater than 225. If it is greater than 225, just correct the image. Okay. And then we have to use the quantum circuit code and run this code and check the visualizations of an image. So I just show you the practical study. In step 1, we are taken an image, like bone image, and how to enhance the image. Okay, we have written some code for on the cascade tool. Okay, and these all the codes is actually useful for the enhancement. Okay, I will not go to more depth of the code. Okay, I just show you the original image I've taken, which is very much not good in the classical computers because this image is created by the classical computer. But the quantum computer, you can see the enhancement is very good. That means it is a comparison of classical computer and the quantum computers. Quantum computer is enhanced perfectly. Okay, you can observe the first and last image. There is a huge difference. Okay. So that means the quantum computer is, you can apply it for the image enhancement for biomedical image. Okay, whatever the background, but I use the code which is shown here in this. So there are 7 steps to enhance the image. Okay, so this is a real quantum hardware which is enhance the image. Okay. Not the other image I also taken board. You can see the last one is more enhanced. That is done by the quantum computer. Okay, so the quantum computer is helpful for biomedical image enhancement very perfectly, which is not solved by the classical computers. Okay, but with the help of NumPy library files, I am using the NumPy library files to enhance the images. Okay, so one more image, some scan image. You can see the quantum computer is again doing very perfectly. Okay, so now what is the future research in this area? I taken only 3 images without any AI applications. So why cannot we develop or machine give the training to do the to give 1,000 image, and the machine will predict the output or enhance the image. So that is a future research you can do because this model or this technique is not developed by any industry. Okay, So now I am stopping here. This is the means project you can do in your future research. Because this up to here I just done this work using the classical computer and the quantum computer. I just compared these two images. Quantum computer is more better. But I not integrate the quantum computer to machine learning. If you use any machine learning algorithms, maybe SVM or bagging boosting, then the enhancement will be more superior. Okay, so that is a future research. Okay, that is possible in the future research. Okay, one quiz is there for your knowledge. You can tell me what is the correct answer for this question. Which quantum phenomena allow qubit to be correlation to another particle? What is the probability? Huh? Superposition, decoherence, entanglement, or interference? C. Superposition. Actually, the correlation is like a entanglement property. It is an entanglement property. C option is correct. Okay, one more last question is for you, like a quiz. You can check your knowledge. In a projective measurement, the qubit state is alpha 0 plus beta 1. What is the probability of measuring the output 1? So alpha square or beta square or alpha square or alpha square plus beta square or 1? C. C or B? No, actually the 1 is associated with beta. So beta value must be high because the output is 1 and 1 is associated with beta. 1 is associated with the state vector. Okay, now I am stopping my lecture. Okay, any question from participants? You can ask any question. If you have any question. Okay, so I think any questions, sir? Yes. Okay, participant, you have any question? So you are welcome to ask your question. I am ready to give your answer. So you can ask online because you just unmute yourself and you can ask your question or if some whatever your research work or anything. Yeah, I think there is no question from the participants. Okay, so thank you very much to all the participants who carefully listen my presentation. I'm very thankful to all.
Sir, thank you so much for our energetic lecture and accurately explained what are the agencies that referred quantum computer technology and successfully simplified the how the fund was allocated worldwide. So we explained different manner and a simplified manner. So thank you so much. You are explained a lot of tools and those are the helpful the medical devices and basic. So thank you so much.